Okay, once again, a very, very good evening, our very amazing professionals of the Society of Petroleum Engineers Abuja section. You're welcome to our monthly technical meeting. This month, we are looking at innovations in oil field technology. Today, we are pleased to have an innovative entrepreneur speak to us on the downhole electric wet connect. Of course, the handset coupler and a career of inventive solutions. A very warm evening to you. Like I said earlier on, if you just want to make your friends learn so much from this section, share this link to them. Of course, this event is live streamed on YouTube. You can always go back to SP Abuja section page on YouTube and you watch our current webinars and past webinars. And of course, you can learn so much from our amazing array of speakers. If you can see my screen, we have the agenda for today's event. After these opening introductions, I'll give a safety brief. And after the safety brief, I'll recognize a few of the speakers that have joined us for today's event. And after that, we'll have a welcome remark by our section chair, the leader of the section. And then we have the speaker speak to us for about 30 minutes. After his 30 minutes presentation, we have about 15 minutes to ask him questions. And once you're done with getting responses to your questions, we'll have a closing remark by the program's chair, Professor Kafayat, who is also on the call. So let me continue the event by saying a warm welcome to all of our distinguished professionals from all parts of Nigeria that have joined this call. Probably you should just drop a chat. Where are you joining us from? Let me see where you're joining us from. Which part of the world are you joining us from? Let me see your chat in the chat box, your name and where you are joining us from. While you're doing that, I'd like to start by saying a warm welcome to our leader, the section chairman of SP Abuja section, the man leading the section to greater heights, the amazing engineer Ikechukwu Okafor, PhD. A warm welcome to you, sir, and a very, very good evening to you, sir.
Thank you, Akwan. Good evening, all. Welcome to the April meeting. It's good to be here. It's good to have you all.
Amazing. Thank you so much, sir, for all you do for the section. We also say a warm welcome to the programs chair of SP Abuja section, also on the call, the amazing Professor Kafayat Adeyemi. Warm welcome to you, ma'am. A very good evening to you, ma'am.
Good evening, everyone, and welcome to our monthly technical meeting.
Amazing. Also on the call is the programs chair 2 of the section, Dr. Yetunde Alaiditane. Welcome to you, ma'am. Welcome, ma'am.
Thank you, Akwan. Good evening, everyone on the call. Glad to be here.
Yes, we're also pleased to have the man in charge of publicity on the call, the phenomenal engineer Odafe Atebe. One welcome to you, sir. Thank you for joining us. Okay. And of course, the man in charge of SPE case, of course, Justus Igwe, we see you on the call. Welcome all of our senior members on the call. Welcome all members from all parts of Nigeria on the call. And of course, we say a warm welcome to our speaker. The man will be listening to an inventor in the oil and gas industry with over 60 patents. Of course, the co-founder of Hansen Downhole Pump Solution. Welcome you, Henning Hansen. Welcome, sir. Thank you for giving us and spending your time for us, sir.
Thank you.
Okay. While I was recognizing him, I just saw that our treasurer just stepped in, Engineer Nana Rimtim. Okay, I'm seeing your comments. Ibrahim Kado joining us from Lagos. Okoye joining us from Port Harcourt, River State, Nigeria. Oluwafemi, welcome. Joining us from Port Harcourt. We have many from Port Harcourt. How is the administrator managing you guys over there? Salim, joining us from Lagos, Nigeria. Nicholas from Port Harcourt. Wow, Port Harcourt is taking over the call. Warm welcome to all of our friends from Port Harcourt. A quick safety brief. You kindly appeal, ladies and gentlemen, that for the course of this event, if you're not speaking, you leave your microphone on mute so it may not cause interference when a speaker is dishing out intellectual information. Raise your hands if you want to speak. Just go on your device, either the bottom or the top. If you're using a phone or a laptop, you'll see the device where you can raise your hands. Use the C for comment. and the queue for questions. Of course, ensure you can hear the fire alarm with your headsets just in case you're outdoor. And of course, be alert and aware of your environment. We appeal that you stay safe, and of course, we would have a very amazing deliberation. Yes, I'm still seeing your chats. Keep dropping the chats. We want the chat box to be very, even our section chair is joining from Port Harcourt. Amazing. I guess that's why everybody is Port Harcourt, because the leader has gone to Port Harcourt. Amazing, sir. Amazing, amazing. Okay, Dana is also joining from Port Harcourt. Welcome, welcome, welcome. Of course, this event is hosted in Abuja. Abuja Station owns the event. So please, Port Harcourt people, don't hijack our event too. Once again, a warm welcome to all of you. At this juncture, Your Excellencies, ladies and gentlemen, we'll be listening to the man who is leading the section right. Of course, an accomplished lecturer, a professor, but is still called a doctor. Help me welcome Engineer Ikechi Okafor, PhD, Section Chairman, for his address. Sir, the stage is yours.
Thank you, Akwan. It's good to be here. It's always good to have the audience of SC Abuja and have us deliver like we've always done. I want to say a warm welcome to everyone. From our speaker of the day, Mr. Henning Hansen, who is joining us from Stavanger in Norway. A warm welcome to my program chair, 1 and 2, Professor Kabakadeli and Dr. Yetunde, and to my good friend and brother, Dr. Atebe, and to every of the board members. A warm welcome to everyone who has joined, or wherever they've joined. It's great to have you here. To do what SPE is known for. SPE as an association is known to have the core value of sharing technical knowledge as it has to do with the safe production of oil and gas resources. And so today is an opportunity to have a session where we're going to speak about innovation in oilfield technology, the downhole electric wet connect, and a career of inventive solutions. The topic quite opens us up to the possibility we're about to meet into, where a lifetime of innovation and solution will be best for us to understand. When Akpan was introducing the speaker, he said he has had over 60 patents. That's huge. And so to afford us the opportunity to sit and learn as we speak is something I take very dear to my heart. And so on that ground, I want to say welcome to everyone who has joined. SPE Abuja is committed to standing on the core value that inspires our connection to SPE, which is the value of technical knowledge dissemination. And today we want to do that again in our April MTM. Welcome, sit back and have an amazing time. Thank you.
Thank you. I think our section chair deserves some virtual applause for his very brief yet insightful welcome remarks. Thank you so much, section chair, for motivating us to stay through this lecture. Ladies and gentlemen, yes, section chair has told us about the topic and innovations in oil field technology. Of course, the session that is about 30 minutes will uncover the evolution of the downhole electric wet connect and the inventive thinking behind solutions that are changing how we engineers operate below the surface. So of course, if you're a tech enthusiast, you're an engineer, you're an energy professional passionate about cutting-edge tools that enhance efficiency, then this session is for you. Of course, we switch gears to introducing the man who would take charge of the next 30 minutes. Please, your eyes on the screen. Henning Hansen is a serial entrepreneur and a prolific inventor, having co-founded over 15 technology and service companies and holding more than 60 patents. Most of these ventures were built on his own innovative ideas and technologies. With a background spanning wireline, well testing, completion, subsea interventions, and more, he has developed groundbreaking solutions such as permanent downhole reservoir monitoring, pump down intervention systems, downhole electric and hydraulic pumps, robotic rig floor technologies, and distributed fiber optic sensing using semi-flexible carbon rods. His inventions also include electric wet connect technologies, downhole heating systems, advanced wire robotic interventions tools, and bismuth alloy sealing systems with electric heating. Hennings previously consulted for Statoil on the Christenfield HV completions project and served on the board of Sensonet, where he helped transition the company from research to a full-fledged oil service provider. Ladies and gentlemen, of course, he will be taking us on innovations in oil field technology, the downhole electric wet connect, and a career for inventive solutions. Please help me welcome the co-founder, Hansen Downhole Pump Solutions, Henning Hansen. So the stage is yours for the next 30 minutes.
Thank you. I hope you can hear me now, and I will try to share my presentation here so we can get that started here. 1 second there. Now I believe you see the presentation. Can you confirm that, please?
Very well, very well.
Okay, thank you. Well, thank you very much for inviting me to this SPE meeting. I'm very honored and very pleased and impressed to meet you all, and it sounds like a very good section. I have some background from SPE myself also, because I was involved in the early start of the SPE section in Stavanger, Norway many years ago also, and I was also the board of directors, and I have to say it's a very good arena, and it's a very good place where you meet people that later may become your bosses, or maybe your clients, or maybe your suppliers. So it's a very good place to be there. So thank you very much for inviting me today. So I will first have one slide, and then I will introduce you to my good old friend. Sorry, I'm saying old there, Nicholas, but my old friend Nicholas Tudor, who will talk a little bit about he himself and his company, because he is one of your neighbors down there and so on. Huh? So today I'm going to talk about one of the companies I'm involved in, that is called Hansen Downhole Pump Solutions, AS. And there's two main technologies we are promoting in that company, and that is a downhole electrical connector system, which we will focus on today. That's on the right-hand picture, on the bottom right. And then we're also doing pumps, actually wellbore pumps, hydraulic, and also gas-driven pumps and so on. Huh? So we have in-house competencies in designing and building and testing and everything of downhole equipment, very complex equipment if we need to. And we do most of the manufacturing outsourced, but get it into us and do all the testing ourselves and so on. Huh? Yeah. So I'm gonna now quickly just let you say something, Nicholas. Can you hear me?
Yes, I can hear you. Good evening, ladies and gentlemen from SP Abuja branch, where the existing protocols duly observed. My name is Nicholas Tuedo of Nequips International. We're based in Port Harcourt. We're into oil and gas services, equipment rentals, downhole tools, maintenance, etc. And our partner, Hansen, based in Norway, is a specialist in downhole tools with over 30 to 40 years hands-on experience in the oil and gas, with several patents to his credit. And recently we got approval from the NUPROC for the deployment of the Wet Connect Hansen Coupler technology in Nigeria oil and gas field. So I want to encourage us to pay attention because we have a saying that when you're looking for the eye of a fish, you go to the head, and Hansen is one of the best enhanced downhole tools. We will learn a lot from him. Thank you, Hansen. You have the floor.
There you go. Thank you very much, Nicholas. Yeah, and as Nicholas said, also we have known each other for many, many years. So, and we're still young. Yeah, so that's good. Yeah, so I have experience. I started in 1979, which is some years ago. And then I started with Baker working in the North Sea and did Weiler, but then I worked international and I was involved in well completion and downhole testing and so on. And I've been involved in downhole permanent sensor systems, in wireless technologies and underwater data communication, actually sending data and commands, for instance, from a surface vessel down to something on the seafloor. Also been involved in artificial lift, which I'm still am, and also complex downhole well intervention tools, also electric heating, and also a casing and tubing with electrical cables implemented. So I know a bit about sensors and cabling and complex equipment in the wellbores and so on. Huh? There's two links there to web pages. One of them is to a web page I call Active Completions. That is because some years ago, SPE asked me if I could do some presentations on the history or startup of intelligent completions. Where did it come from and who did what and so on, and what technology was it based on? So if you look at that website there, you can read about the early days when we started installing cables and sensors in wellbores. And we were one of the first ones to do that. And now you see most offshore wells, especially subsea wells, they have some kind of sensors. Or now it's more and more common to have more intelligent completion systems and so on there. So I have, after I worked with Baker, I had some new ideas and so on, and I co-founded some companies, and I've done that 16 companies up to now, and still doing it, I think, and so on. And basically, it comes out from ideas I have. It could be for methods or technologies and so on. And some of these companies, some examples of those is many of those you will not know of actually, because one of them, the first one I started was called LaSalle Pressure Data. There we developed the first permanent reservoir monitoring systems using the type of cable and encapsulation that is used today. And that company there, we also set up a company in the UK. The company UK was later bought by Baker, and that was the first reservoir monitoring business Baker got into with electric sensors and cabling and so on. Huh? And then LaSalle Pressure Data today is known as Roxar, which is a big supplier of downhole reservoir monitoring systems. That was in 1992. Then I co-founded a company called Subtech in Norway. There we wanted to develop some much more complex systems. We really focused on subsea wells. We focused on having many sensors on one cable, and we also developed so-called intelligent completion systems and so on. That company we sold to Weatherford in 1999. So then I worked 3 years with them in the intelligent completions solution system there. So the sensing systems and the intelligent completions they have also originated from the company I started then. Then after working some time with Weatherford, I had more ideas. I wanted to develop more technologies, and some of them was not in line with the technologies that Weatherford did. For instance, one of them was actually developing a drilling rig, and really Weatherford was not into drilling rigs. So I joined in the board of directors of a company called Sensornet in London. That was Shell that asked me if I can help them. They're building it up from a two-man laboratory type company to a service company. So I spent some years there actually learning a lot about distributed fiber optic sensing, acoustics, and also temperature. But we also did vibration measurements and so on, and other things there. So that became a company which is today part of a company called Tendeka. So that gave me very valuable learning about this fiber optics sensing. So the company I co-founded first after Weatherford, that was a company called Seabed Rig. I came up with an idea of how you can design and operate a drilling rig which has no people on it, but it's sitting on the seafloor. So all robotics and remotely operated and so on. So we started developing other technologies, but then we got contracts for supplying robotic drill floor or pipe handling solutions to the North Sea for ordinary offshore platforms. So that company today is called Canrig Robotics and is part of Nabors, which is a drilling rig manufacturer in the US and so on. I also co-founded two other companies. One of them was called Siebel, and the other one was Sealift. Siebel was actually taking what I learned about fiber optics, where I developed a semi-stiff carbon rod, which you push into wellbores just like you do with coiled tubing, and that did distributed logging. So we did logging there of entire wellbores and so on. We did a lot of horizontal wells, and that system is still out there now. It's part of Baker. The other one I came up with was an electrical downhole pump. That was a pump based on permanent magnet motors, and I think we were probably the first ones to take that technology into use in wellbore applications. That company was based in Aberdeen and became later a part of Schlumberger, or SLB as it's called today, and so on. And when working with these complex electrical pumps, I always thought that actually, well, there's a lot of onshore wells which is producing not that many barrels. So I always wanted to develop something less complex, and I've done that also later and so on. So I've developed pumps which pumps from 20 barrels a day, maybe to 3,000 barrels a day and so on. And last 8 years, I've been involved in a company called Arbach Innovation in Norway, and there I put quite a few patents in and developed quite a few technologies. For instance, electric heating in wellbores. We developed there heating systems that can heat the near wellbore to 800 degrees. But we can also heat much less, for instance, for melting hydrate plugs on wireline and things like that, also heating the wellbore fluid flowing through these heaters and so on. For instance, if you have wax problems or paraffin and so on. Another one that I came up with was actually a tool called today Axtor. That is a very complex and impressive, I have to say, a wireline tool. That can do scanning. We can see how a tubing looks like. We can see actually how a wellbore device has been machined in there, if there's any borings or penetrations in it. And we can also do machining and robotic operations on that one. So that is a tool that can go down and scan. It can create a window or mill a window in the tubing. It can find a cable on the outside and retract and cut that and remove that cable, for instance, if you want to. So that's what that tool is doing today. That extra tool is today launched worldwide through a collaboration with Welltech, which is the Danish well tractor company. And also I'm involved in a company called Wellstrøm. That is actually melting bismuth alloy using electrical heating and so on. That is for creating barriers downhole. And then I'm also these days quite active in a company called Storage to Power. That is actually something that started because I was asked by an operating company. Actually, is the way to create offshore power without CO2 releases and so on. So I came up with a system actually using a buoy system that harvest energy from wave and also from underwater currents, and also store that energy for using. So the target there is actually deliver power to small offshore platforms. It could be for retrofitting pumps, and it can be for plug-in abandonment, etc. So yeah. So that gives you just a little sense of things I have been involved in. So this is the electrical coupler I'm going to talk about. Actually, on the right-hand side here, you see a photo of one of the first ones, actually, and the electrical section of it itself, that is just that shiny object there where you see the silver-plated rings there. Everything else in this one is actually the mechanical operation and mechanical locking and so on. But the whole purpose of this connector is actually that I have some slides I'm going to show you after this. But it's really to get sensors into the reservoir in deep wells or long wells. It's a difficult thing, maybe sometimes to run the well completion all the way to the end of the well, to the toe of the well. So then you have to run it in 2 or maybe 3 stages. Actually, you run in the first one, then you have the connector between the first one and the second one, and then you can get the power and data that you need. And of course, as you know, actually, the more sensors you have in a reservoir section down here in the sand phase, the better information you can give to the geologists and also the production engineers, and not at least the reservoir engineers. They use that data to monitor what's going on in the well, how the well injection is working and so on, and water flooding. And actually, you produce more every day because you can draw down the pressure closer towards the bubble point, or the gas breaker. And you can also produce more from the reservoir. So my experience with having sensors in well bores is that subsea wells, typically you produce 15%, 10-15% more per day using sensors there, because you can balance the production much more. So let me see there. Yeah, okay. So here I made some sketches actually to try to illustrate what this is all about and so on. Why we developed this electrical connector. For instance, sometimes you have very long horizontal well bores and so on. Huh? And then when you try to run in with the well completion, which is the orange part there, you get to a certain stage, but you cannot really get all the way to the end there on the well bore. So what you need to do then, actually, you need to install a lower completion first. And that completion will have sensors on it, but we can also have electric valves and other things on it, actually. So you can control and adjust flow or injection on that one. So that's what they call intelligent completions. And then between the first completion and coming in with the second completion, you need to have an electrical connection here and so on. So that is what this is about, actually. You come in with the upper string, which goes up to the wellhead, and you have a cable on it, and you have some sensors if you need that. But then actually the connector contains the bridge between the upper and lower completion. So some of the wells we're doing right now, actually, they run it in 2-stage completions because they are doing gravel pack. They run in with the screens and packers and everything, and then have a wash pipe in it and pump gravel on the outside of the screen and everything and so on. After they've done that, they pull out the running string, the wash pipe and so on, and then they come in with the upper completion and connect in here. And of course, the challenge there is really that gravel packing typically leaves quite a bit of sand and debris in the wellbore. So wellbore cleaning is extremely important in those wells. And we learned that the hard way, that it really need to be clean. So hopefully you can understand that this connector is the main use today is actually providing electrical power and signal for equipment further out in the wellbore. Of course, the connector can also implement hydraulic connections if you want to have hydraulic valves down there, or if you want to do chemical injection or something like that, we can also implement that in the connector as well. So typically what many people forget about the electrical wet mate couplers, actually, that if you have trapped seawater, brine, or something in the area where you have the electrical contacts, actually, just imagine if you have a male and a female, and if they are connected in that fluid there, it's just a matter of time before they will fail. So removing that is extremely critical. And you typically see the same thing that of the companies that are making underwater connectors. They always have some silicone oil or something like that where you connect in. That is much more difficult to do in a wellbore, so that's why we came up with a solution that does that. So if you see that somebody has an electrical connector and they do not remove the wellbore fluids, they just isolate it, I am really skeptical about the reliability of that equipment and so on. So this is quite an old patent now, actually. It was filed in 2011, and I filed it actually based on actually how could we replace electrical pumps using wireline. Then we need to have an electric connector. That's how it started, but it also describes how you can use it for the application I'm explaining to you right now. But also it explains actually that this oil discharge in it actually to wash out or replace the wellbore fluids and so on. But I think the most important thing there is that actually that we have built quite a few of these now. We have done a lot of testing and learning, and there's more patents being produced. That is quite typical, you know, as was mentioned also, I have more than 60 patents, I think 65 or something. And I don't know how many patent applications I've filed, but it's a lot. And what you learn sometimes is that you have a patent application or you have a granted patent, but then as you're developing a technology, the first patent, you drop that one because you learn to improve the quality of the patent later on and so on. And we see that also here, no doubt about it. But I think also what's important also that we have in-house competence. We know about sensors and cables and wellbores. We know how it is used. We also know the value of the importance for the end clients. We can talk to the reservoir engineers and so on and explain to them actually why would you need to have sensors in the wellbore. So what's the winning of that one? How do you get your money back from that one? And also, you know, I worked on intelligent completions or some it's also called DIACs, which is downhole instrumentation and control systems, which is, I believe, a better expression than intelligent. I worked with that for many years and know how that works and so on. They come from the lower complexity to the very complex there and so on. We have also learned a lot about electrical insulating coating and so on, because if you have an electrical device in a wellbore, you need to have some coating, special coating to prevent electrical shorts and so on, because it's just coating with an ordinary Ceylon or one of these things actually. It looks good, but there's definitely some challenges. We learned the hard way actually how to do that and so on. But I think also what we done a lot of testing. We did all kinds of brine testing and low pressure and high pressure, and we done temperature testing and everything on that one. And I think the learning from that is really that got us where we are right now and so on. So I designed the first electrical wet connector for the subsea tubing hangers in 1987. That was the first electrical coupler for subsea tubing hangers and wet trees and so on. So we installed probably 24, I believe it could be 50. I'm not sure because the company was sold later and other people took over later and so on. I've also used it in seabed data logging systems. So to the right there, you see some photos actually. That is hydroacoustic data loggers we used on downhole sensors. We installed, and we may have still the world record, where we installed 132 sensors in one subsea well, plugged it all off and had acoustic communication from the seabed to the surface and on. So we were also the first one to do that one. And using the same connectors actually, but modified from the downhole use and so on. I also designed a wet connect for side program mandrels. Just like you have side program mandrel for gas lift, we developed a side program mandrel with electrical pressure and temperature sensors in them, and we had those sensors wired and replaceable. So that's why we need to have a electrical connector in there. So we learned a lot about actually the downhole connecting and so on. So the one we have now, actually, we spent more than 3 years actually developing and testing it. And to be honest, we had some serious failures, and that's what you learn from. And you just have to be stubborn and very patient, which I am sometimes. And you have to have a good sense of humor. That is a good spirit for the team working on that. And we got it working. We did a lot of repeated testing, make sure that everything worked, and we believe today we have a very good product and so on. So here you see some of the testing. Actually, we did oil discharge. We did a lot of stabbings. We did pressure testing and temperature testing and electrical insulation and conductivity, shear pin testing and so on. And here you see one of the on the picture down to the left there, you see one of the connectors that are being tested. This is a mechanical testing we did, because the shiny object you see on the right there, that is the female connector. Above there is a packer, and here you see the upper connector coming in, actually, which is from the upper completion with electrical contacts on them and so on. And then you have some latching mechanism. All this latching mechanism we had to test a lot also, because that is what's used when you space out the tubing hanger. So first you land the string and you say, okay, I have the depth. Then you have to pull it up again, install the tubing hanger, and then do the final landing. To do that space out, you need to know actually when shear pins shear and when you land and so on. So complex testing had to do that one. And as I said, did we have failures? Of course, we did. And then repeated testing and repeated changes, and we got it working. And now we have a product that no doubt passed with flying colors and so on. So the versions we have actually is, we have one for 5.5-inch tubing, where you install that in 9.5/8-inch casing. That is for one electrical conductor coming from the surface or the wellhead down to the sensor and so on. It's a single stab. Actually, we have a single discharge. When you land that one, it discharges all the oil, and that's it, and then it's finally mated and so on. Huh? We have another version also, which is a smaller version, 3.5-inch, and that's for 7-inch line and so on. That's a little bit more complex because that have 2 electrical cables. But we can go up to many more electrical conductors if we need to on this one. We have the design for that one, and also doing the hydraulics and so on. So we did complete the testing in 2024 on that one, and the testing was very comprehensive on that one. And on the drawing down on the bottom here, you see the female unit, which is connected to the string below. And up here, you see some ratchet mechanism. That's how we can latch in a running tool and rotate the lower string if you need to. And here you see the upper connector. There's a stinger there that lands in and latches, and there's a latching mechanism. Then you know you latch in, and you can pull out again and do the space out of the tubing. And then you have electrical contacts, actually, around that one for the cables. And these contacts and so on are very rugged. They are machined of one piece of metal, and also silver plated. And silver plating we do to have very good electrical contact, but also for the reliability and low corrosion on that one. And then up on the top here, that is actually where we connect to the electrical cable going up the wellbore. And also this is where we have the oil chamber and so on. Huh? So right now we're working on is a running tool for this actually, so we can run that one and still have electrical contacts or signal to the surface when we do that, and also other dimensions, and also implementing wet connects and so on. And also we want to implement also a pressure and temperature sensor in there, because typically they want to have a pressure temperature sensor at this location, and we can easily do that and so on. We're also upgrading it for much higher power uses. So that's going back to where we started, actually. I started with an idea for electrical pumps, and that's also where we're going with this one, huh? Yeah. So, yeah, so the first one we did, actually, we've installed 7 of them. Now we have installed 7, and they're all in deep water wells. We had one failure, and that was actually mechanical failure, because as I told you, actually, it's doing gravel pack, so there's a lot of debris there. We had problems cleaning out the well, so we actually had mechanical damage when landing it, which is something we learned, and now actually they have much better cleanup operations in the wellbore there. So that's good. Yeah. So there's going to be quite a few more of those installed. On the photo, you can see that version there. There's a stinger here that lands into the lower connector, the female. When it lands, this stinger is pushed in, and that displaces oil in this section here between all the seals, and this is where the electrical connector in. So the oil will be placed between here and the female connector. All up here is just a centralizer to make sure that we don't damage it going in the wellbore, and all the latching equipment is onto it. Huh? The other one actually we did that we designed one for one of the large intelligent completion companies. Actually, we completed that one, and that can do a lot more connections. Actually, we have the displacement of oil. We can do 10 times on that one. So that makes it a product which is easier to do when you have problems, for instance, spacing out the tubing hanger and so on it. Huh? So here you see it's on a test bench. We did a lot of repeated stab-ins and testing on the test bench of it to see that everything works and measure the oil discharge from it and so on. And I think next page here is actually that shows you actually some of the testing we did there, and it's a pretty good explanation of how the tool works like or looks like and so on, huh? So here you see the electrical connectors and so on, and the people who are testing them. Here you can see actually we entering the female with the male connector and doing all the measurements we need to do there on that one. So we did repeat the testing, a lot of testing on that one to make sure that everything works and so on. And yeah, so here you see seals, and you can see it's all connected and so on. And here you can see oil coming out. You see some of the oil dripping out there. So there's two locations oil comes out when this is actually, but you still have an overpressure on the oil in the connector. So it's a very good testing. It showed actually that all the oil volume we needed, actually that is what's discharged, and it works. So here you see these are the people designing it that you see on the video here. So I believe actually the people designing it, they should not just sit at computers designing. They also need to go down and participate in assembling and testing and so on. And my experience also, they love that. They have a much better feeling about what they've designed and can also follow up on that one. Huh? So I'm not sure how much time we have, but I can quickly go through these also because there's always some safety issues when you handle this equipment. It's mainly because it's heavy equipment. For instance, these are components. This is 400 to 700 kilos, you know. So lifting and so on, that's important to have a proper safety around that one. Pressure testing also, you know, I've seen some bad accidents many years ago where the pressure testing actually. So it's important that you use certified equipment, that everybody knows actually what you're doing. It's also important that people knows the dangers of pressure testing, because 5,000 psi or 10,000 psi is a lot of energy and so on. Huh? So we have procedures for that one. Also the lifting from the rig floor and so on, and all this is shared with the people there. We also have, for instance, what if you don't get a signal? What should you do then before you panic and so on? And that typically what it is, typically it's at surface. It's a loose connection at surface on the reel from the cable and so on. And you quickly find out with these procedures and so on. But there's procedures actually how to manage that one. So a lot of these will be shared also and so on, or shared with you and so on. So these are some new ideas I'm going to show you now that we're working on. That is actually that, can you prepare a wellbore for future more complex use? Because quite often you install a well completion equipment, and then after 5 years or 7 years or maybe shorter, you see that, oh, I should have had some more sensors in there, or I should have had some more valves or something to control the wellbore and so on, the inflow or the injection to it. So that's actually based on actually this technology you can use for that. If it is an electrical connection or hydraulic connection in the wellbore, if you have creativity, you can think of many uses for this one. So I'm going to show you a little bit of that one. So here's, for instance, one example that, you know, this is more or less actually, well, you have a well completion, actually, you have sensors downhole, and you install a female connector in here and so on. Huh? And this connector here is actually just it has a protection sleeve in it, so it doesn't do anything as long as you need to and so on. But then actually, if you need to do something, you can pull out that protection sleeve, and then you have an electrical contact available for installing something in the wellbore. Huh? So here, the same sketch up here, actually, you have that one. We have removed this protection sleeve, and then we have installed actually a connector, electrical connector again, and then we have a completion system installed in the wellbore. And that could be, for instance, that you need to block off some inflow areas or some injection areas, or you want to have more sensors in the wellbore. That is fully possible with this one. Also, what we implement in this one is actually, if you have a failure on the cable or the sensors further downhole, we can isolate that one. We can disconnect this cable and route the signal into the cable going into the insert string. So suddenly you get your sensors back. It's new sensors, but you get all the monitoring back, and you can do what you need to do there on that. So here you see actually it's just more or less the same thing. Actually, you can have also a system where you don't have sensors initially, but you have an electrical connector in here, and you may have sensors further up and so on. And then later, after some years, or maybe 6 months, you find out I need to run some sensors in there because I really need to understand what's happening in my wellbore. Then we run in with this string here with all the sensors on and so on, and you maintain the injection or the production, and you get the data or the control that you need to, and so on. Huh? Yeah. So yeah, this is also, what I also believe is possible actually, many times offshore or subsea and so on, to do a recompletion or running long string can be a challenge, can be very costly, and you may not have a stiff riser long enough and so on. So then I'm working on actually how can we install those with wireline, for instance. Can we install an intelligent completion with wireline? And here you see actually how that can be done. You have shorter assemblies, which is the length of the lubricating system you have, including whatever riser you have and so on. And you have electrical connections between each assembly. So then you run in one by one until you land in the one in the old connector in the tubing string and so on. So there certainly you can have an intelligent completion retrofitted by wireline later on. Huh? Yeah. Here's another one also, I'm also doing, and that is actually electrical safety valves are coming out. There's also some already on the market, but there's more coming out. And this can be used also for providing electrical signal to a wireline electrical safety valve. Could be on the same cable as the sensors, or it could be a separate cable and so on that one. And we can also have this disconnect function for sensors or whatever below there if you want to just have priority on the safety valve. But also, of course, as I said, I'm also involved in electric heating systems and so on. That will require some much more power than we can do now, but that is what we're working on right now. And then you can have an electrical connector in here, and you can land an electrical heater in there, which heats the production flow, avoiding paraffin or things like that. Sometimes you can also see the wells flow much better if you heat the fluids and so on. Huh? That also happens and so on. And here's the latest one. I'm sorry about the sketch, but it's actually how I normally start. I start with hand sketches to explain what it is, but this is actually how can we use this for electrical pump and so on. Huh? And then, my idea there, the plan there was actually, we will have a standard ESP system, actually, the motor and everything. And then we have a no-go or latching mechanism implemented. Here you have a traveling piston, actually, with the upper part will land under that one. It displays oil in this action when we landed. Here we have the electrical connections and seals and so on, and then we have the pump intake, and then standard pump above here and standard ESP below there. So it's not really rocket science. It's just a matter of a solution where we can do anybody's electrical pump. If it's electrical, we can implement this one. Where they normally connect their cable, we can connect our system. So the way it would be in the wellbore, we would have this sub here, which has the electrical female connector in it. There's bypass tubes here, actually, where all the flow is going past the motor. You have all the cooling you need. It comes up here, passes the electric connector, and goes into the intake for the pump. And then it's brought to the surface. So here you can install a pump by wireline, and you can retrieve it when it fails, because typical pumps, they do fail after some time. And you may have several of these to get more production and so on. Huh? You can also say that, well, I'm going to have a tubing deployed ESP, but I'm going to have a coupler, electrical coupler up here. So because if the tubing deployed ESP fails, it's too expensive to replace the well completions. So I'm just going to run in with a wire and deploy the ESP. And that is possible. We can do that with this technology. Yeah. And yeah, so here is another one also, actually, basically, maybe, sorry, a little bit complicated sketch, actually, or drawing, but it's a way, actually, that sometimes you have restricted size in the wellbore. to get the number of barrels you need. But actually, you can have several pumps in a series, and you can have, for instance, 2 pumps is enough to produce what you need to do or what the reservoir can deliver, but you have another pump as backup. So then if one fails, you can switch over to the backup pump and still have 2 pumps, or you can replace pumps also and just leave the tubing mounted dead as it is, but still produce the wellbore. So then this is the last slide I have. I hope it was not too boring, but as I say, I'm involved in downhole electric heating and so on, also in placing bismuth or melting metals in the wellbore. Also, I'm doing a project where we remove the cable outside tubing and so on, and have electrical connections in the tubing. So when you run a tubing string where you have sensors and telecompletions, you don't need any cable clamps or cable protectors or any cable on the outside. And you can really remove the number of people on the rig floor doing this one, and much safer operation. And also the offshore energy generation, storage and delivery also I'm working on. And also this complex wireline technologies. And I hope I can be able to also present that one day, because that's quite an interesting, fascinating technology. I say, and many people agree with me, I say that in wireline we have had 3 revolutions or really evolutions. That was when somebody invented wireline many years ago. Then some years ago, somebody came up with a wellbore tractor, which really made much more possible in the wellbore. And then we came up with this Axtor robotic technology, which can do machining and scanning and all kinds of things in the wellbore and robotic operation. So suddenly there's so many things you can do with wireline that you normally would need to do with coiled tubing or pull the completion and so on. And another one also, which is a little bit wild one, but that is actually something we're working on. Actually, the target is to drill with a cable. Instead of having drill pipe, we drill with a cable, and we can drill very long wellbores with that one. And it's for civil engineering. For instance, it could be used on land for water or cables and so on. But also it can be used for geothermal and also oil and gas. So that's also a fascinating project there. I think that was the end of my presentation. So I think we can open the floor for questions, and I hope everybody heard me.
Oh, okay, thank you. That's very. So listen, we have asked now about me sharing the excuse now. Want to speak, and you begin to speak, please, for the 9 minutes of opportunity to ask question.
Of course, it can seem a little bit complex, maybe some of the things that show there and so on. So remember this, as I always say, there's no stupid questions, but I'm quite good to come up with stupid answers sometimes. Yeah. Okay, here's a question. Yeah. So let's see. Thank you for your wonderful presentation. Yeah, thank you, Salim. And then we had bad experience with establishing connectivity with pump down and downhole wet connectors. Okay. With yeah. Yeah, we have not used this downhole wet connector in Africa yet and so on. It's in North Africa, well, which is Africa, yes, it is, but North Africa. And we also used in Asia and so on. And the failure rates, actually, as I said, we installed 7 and we had 1 failure, and that was mechanical failure, actually, that the well was not clean, so we had mechanical damage on it. I see that you mentioned pump down there and downhole wet connector, so I'm wondering if it's that actually you're pumping an electrical connector down and it connects there and so on. I have done that many years ago and so on, and it's the same thing there, actually. The connector you use, it must have a silicone chamber or some means actually to remove the wellbore fluid. Also centralization and making sure that you actually have connected is important. So if you pump something down, make sure that you achieve the pressure that you need to know that you are connected on that one and so on. Huh? But contact me and explain what you're looking for, and I can try to understand and give you a better answer there. And ultrasonic scanning in the wellbore. I'm just reading the question. Ultrasonic scanning, yeah. Yeah, the information available, actually, the scanning we do is in real time. So we see, it's just like going to the doctor and having an ultrasonic scan. We see in real time actually what we're looking for. And we can also, of course, have a report later, but for us, actually, real time was very important because we are scanning to find something, to remove it, or do machining to remove a nipple profile or something like that, or do a robotic operation. We cannot wait many hours to understand what we're looking at or do the analysis on data. So actually, real time is very, very important for us and so on. Huh? But of course, contact me also on that one. We can show you something more, and we can definitely do a presentation on that one. And as I said, actually, this extra technology, I think a lot of you would be very impressed by what you see, because I'm proud of that technology and the team that has done that one. Huh? Yeah. So yeah. So if we have used it in Africa, only in North Africa, actually in Egypt, we've used it and so on. Huh? Yeah, on this one. So I think Nicholas Tudor is the person to introduce it together with us in West Africa right now. Yeah. Mm-hmm. Any more questions, gentlemen? Oh, ladies and gentlemen? And typing them is a good way, then I can read them. Yeah.
Okay, the two questions asked, I believe, Salim Madawaki, I believe you've gotten response to your questions, right?
Yeah, thank you very much.
You're
Okay,
welcome.
Engineer Chidi Mwaikbe, I hope you have gotten response to your questions as well, right?
Yeah, absolutely correct. So I'll contact Hansen maybe to talk more about the scanning aspect of it. Let me see. What?
Thank you.
Thank you.
Okay. Thank you so much. Thank you so much. Please, can we give the speaker some virtual applause? Can we give him some virtual applause? And Mr. Hansen, just in case I want to contact you, where should they reach out to you on so that we can wrap up your presentation now?
Sorry, can you repeat that, please?
Should in case they want to reach out to you, how can they reach out to you?
Okay, yeah. I can write my email address right here, but I think it's on the presentation also. Let me see. I will write it here.
Okay. You can just drop it on the chat box and
Yeah,
they will definitely.
there you go. Yeah. Contact me
Okay.
that email address, and I'm available. Or also contact Nicholas Tudor also if you want to have a local also to talk to. That's fine, and Nicholas can also set up. But email me, and that's super. That's good. Yeah.
Okay, thank you so much. So, ladies and gentlemen, we've come to the end of the presentation today. Are you part of SPE? If you're not a member of the SPE, we'd like to say that our arms are open and you should join the Society of Petroleum Engineers today. Why should you join SPE? Of course, we have several benefits. One of them is this technical lecture you just joined. Of course, we have several technical events which we hold every month where we keep you abreast with technical information in the oil and gas industry. Renew your membership, it's 6,500 naira for new membership. And of course, for renewal, it is just 69,500 naira. Of course, engage our membership chair engineer, Ogenero Meogolo, on the number you see on the screen. And of course, he'll be pleased to guide you on how to renew your membership. Of course, our details is also on the screen. And of course, we are live on all social media platforms from WhatsApp to emails, spabujasection@gmail.com to YouTube. This event and our past programs are live streamed on YouTube. You can always go back and refresh your memory. Of course, we're on Facebook, Instagram, LinkedIn, and Twitter, now called X. We have a distinguished lecturer program which is going to hold on the 28th of May, barely 1 month and 4 days from today. We kindly appeal that you register. The link is on your screen as we have Arti Dange Bat, who is the Customer Experience Director and Diversity, Equity and Inclusion Leader of Middle East and Africa, travel all the way from the Middle East to Nigeria for this deal. You should be part of this deal. It's going to take place at PTDF Towers in Abuja, Nigeria. Ladies and gentlemen, of course, we switch gears to the closing remark. And of course, we'd like to call on the programs chair of SP Abuja section, Professor Kafayat Adeyemi, ably represented by the programs chair 2, Dr. Yetunde Alaiditan, for the closing remarks. Prof. Yetunde, the stage is yours for the remarks, ma'am. Professor Dr. Yetunde, are you on call? Okay. Publicity chair, are you on the call, sir? Dafe Atebe, are you on call, sir? Sorry, is anyone hearing me? I'm just speaking to myself.
I can see.
I hear you. Yeah.
Okay. I was speaking to Professor Dr. Yetunde, are you on the call? Engineer Odafe, are you on the call? Our section leaders for a wrap-up words before we leave. Okay. Just I think probably network is not allowing them to speak. On behalf of the section executives, once again, we say thank you to our amazing speakers for doing justice for today's event. Before we wrap up our event, we normally have a group photograph. So please, we ask everybody to turn on their video cameras. Let's do a screenshot to see ourselves. Please turn on your video cameras. Wherever you are, turn on your video cameras. Turn on your video cameras. Turn on your video cameras. Please turn on your video cameras. Thank you. Turn on your video cameras. Thank you.